Hi, welcome to Odyssey classes. In the series of lecture on circuit analysis, in today's session we are going to analyze parallel circuit. In my previous session, I have discussed series circuit. In case your concepts are not clear, do watch that video. I'll share the link of that video in the description. So without any further ado, let's get started. In the last session, we discussed that there are three types of circuits. The first type of circuit is a series circuit. The second type is a parallel circuit. And the third is a combination of series and parallel. In today's session, I'm going to give you a simple problem solving technique for the second type of circuit, and that is parallel circuit. So the idea is very basic. We know that there are four types of questions mostly asked in any circuit. And the first type of question is to find the total resistance of the circuit. The second is to find the total current through the circuit. The third is to find the current through each resistor. And the fourth is to find voltage across each resistor. I'm sure by now you all have learned these questions by heart. So now let's say you have been given a series circuit. In that case, we generally follow the sequence 1, 2, 3 and 4. That is, we solve question number 1, then 2, then 3 and then 4. Whereas in case of parallel circuit, we just do the reverse. We start with question number 4, then 3, then 2 and then 1. The reverse order 4, 3, 2 and 1. I'm sure if you are a beginner and do not understand circuits much, this simple trick is going to be a great help, and slowly you will be able to build your concepts and understand the depths in each circuit. Now let's do some practice to build our concepts in parallel circuits. Okay. So here we can see a parallel circuit where the three resistors R1, R2 and R3 are connected in parallel, and we are supposed to find the answer to these four questions. As it is a parallel circuit, we will start with the fourth question. That is, we will find the voltage across each resistor. So how do you find the voltage across each resistor? Let's say the voltage supplied by this battery is V. So what is the voltage across R1? If you see the circuit carefully, here each resistor is in one way directly connected to the battery or the supply. Let me just draw another circuit diagram, and here I am going to draw the wires by freehand. So let me connect here resistor R3 in here to the battery. Let me also connect the resistor R2 directly to the source here. And let me also connect the resistor R1 to the source directly. Now I guess you are convinced that the voltage across each resistor is same as the supplied voltage V. Now the previous circuit is not different. What is done basically is this part of the circuit for R2, the connection is taken from here basically, and this part of the circuit is removed. And for R1, connection is taken from here and this part of the circuit is removed. So this is done in order to make the circuit look standard, and we are also able to save the extra length of the wires, so which is commercially viable. So the circuit is exactly same, and what we see, the voltage across each resistor is same as the supplied voltage. So we have got the answer to the first question. We did not do any calculation. The answer is simply there. If you remember the concept that in a parallel circuit, voltage remains same. So here I can write the voltage across R1 is same as the supplied voltage. Let me mention it here. Let this be V volts. Similarly, voltage across R2 is V volts and voltage across R3 is V volts. That's it. Now we are supposed to find the current through each resistor. That is current through the resistor R1, current through the resistor R2 and current through the resistor R3. Let me give it a name, I1. And this as I2 and this as I3. So what are the values of I1, I2 and I3? Now it's very simple. From here we just need to use Ohm's law. So for finding the current I1, I2 and I3, we will simply use the Ohm's law. So the value for current I1 will be V, that is a supplied voltage across R1 and the value of R1 itself. So this is going to give you the current that is passing through the resistance R1. In order to find I2, we can see the voltage across R2 is V and its value is R2. So we can simply use the same voltage V and the resistance value as R2. And I know by now you know the answer of the third part. I3 will be the supplied voltage V that is across R3 and the value of R3 itself. So this way we can easily find the voltage across, the current through each resistor. Just remember that the same voltage is present here, here and here. The voltage is not changing. Okay. Now we need to find in question number 2 the total current through each resistor. So now what we can simply do, we can add the three currents. So if we add the three currents, I1 plus I2 plus I3, we will get the total current and we can call it as I. So we can write the total current as I is equals to I1 plus I2 plus I3. This is the total current that is flowing in the circuit. Okay, the last part of the question is to find the total resistance of the circuit. Now here we have two methods. We can use simply Ohm's law and we can get the answer. So let's say we have to find R. So we can say R is equals to V by I. This is what we know. But what is I here? This I is the total current that we have calculated. Let me call this as IT. So the same current is here. So when we take the total current, the resistance that we will be calculating will be the total resistance of the circuit. Okay. The other way to calculate the total resistance or equivalent resistance is the formula that we all know, that is 1 by R. Let me call this T for total. 1 by RT is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So from here we will take LCM and find the value of RT, that is the total resistance of the circuit. So this is the basic concept or the idea involved in solving parallel circuits. Now let us do some numerical based on it. Before you watch the solution, I will suggest pause the video and try it yourself. Did you try? I hope so. Fine, then let's see the solution. So the first question is to find voltage across each resistor. You remember, in case of parallel circuit, the concept is that the voltage across each resistor remains same. We do not have to do any calculation. Whatever is the voltage supplied here by the source, same voltage is also supplied across each resistor. So let me start writing the answer here. Voltage across resistor R1 is 24 volt. Voltage across resistor R2 is also going to be 24 volt, and voltage across resistor R3 is also going to be 24 volt. So this is the answer of the question number 4. And here we have the answer to question number 3. So for question number 3, we have to find current through each resistor. So one thing what I will do is I will write the values of the voltage that we have got right now. So voltage across R1 is 24 volt. Voltage across R2 we have got 24 volt, it's same, and voltage across R3 is also 24 volts. So for each resistor, you see the values of the voltage difference and the resistance is already known to us. So all we need to find is the current, and for that we always have Ohm's law with us. So we can use Ohm's law to find the current through the resistor R1, and then current through resistor R2, and then current through resistor R3. So let me call this as I1, let me call this as I2, and let me call this as I3. So we can use simple Ohm's law here. So I1 is equals to the voltage that is supplied across it is 24 volt, and the resistance R1, let me write this R1 here, I'll put in the next here 24 volt divided by the 8 ohm resistance that we have, and this is 24 by 8, that is going to be 3 amperes. Okay, now to find the current through resistor R2, so same Ohm's law we can use. I2 is equals to 24 volt, that is the supplied voltage, and the value of R2 here it is 20 ohms. Let me put it here. Now this is going to be in fraction. Let me divide this. This will be, if I divide by the table of 4, I will have 6 and then 5. If I divide this further, I'll get 1.2 amperes. Okay, do not leave the answer in fraction, solve up to decimal. Now to find the current through resistor R3, same formula we can use. I3 is equals to the voltage supplied across it, that is 24 volt, and its own resistance, that is 30 ohm. So this is again going to be in fraction. I'll divide by 6. So this is going to be 4 by 5, that is 0.8 ampere. So this is the current that is flowing through each resistor. Okay, we have 2 more questions. As we know, we have to find the total current through the circuit, and we also have to find the total resistance of the circuit. So let me just write all the values that we just obtained right now. We found the current I1 in the previous slide, it was 3 ohm. We can write it here. The current through R2, we got it as 1.2 amperes. Let me confirm, yes. And the current that is flowing through R3, we obtained it as 0.8 amperes. So this is the current through each resistor. So now we can solve total current. So the concept that we know already is that we can just add up all the currents I1, I2 and I3. When we add all the currents, we get this as a total current, and the total current I is nothing but the sum of the total current I is the sum of each branch current I1 plus I2 plus I3. So we can put the values here. We can write this as 3 amperes plus 1.2 ampere plus 0.8 ampere. It's a good value. This is coming as 5 ampere. So remember the concept. In case of a parallel circuit, the total current is the sum of current through each resistor. We just have to add all the values. This is done already now. Now the last part, this is your question number 2, and now we can solve question number 1. We need to find the total resistance of the circuit. Now whenever we are finding the total resistance of the circuit, I'll always ask you to imagine a circuit like this, where we have only one resistor and the supply source. So we need to find one resistor that will be equivalent to all three here. Okay, so this is what I'm calling is as R total, and this is this resistor that is replacing all three in the above circuit, and this is the same supply voltage 24 volt. Okay, so here we have to find the total resistance. For this, we remember the concept, we have to use simple Ohm's law in this circuit. Okay, in this circuit we'll apply Ohm's law. We'll apply Ohm's law here in this circuit and we will get the answer. So let's see how. We know the total current I is equals to 5 amperes. So can we mention this in this circuit also? This is 5 ampere current flowing in the circuit here, and the value of total resistance RT is not known to us. This is what we are supposed to find, but we do know the voltage across it. So we can use a simple Ohm's law formula and write RT, that is a total resistance, is equals to supplied voltage by the total current. If I call this as IT, the same current, we can use it here and we can obtain the total resistance. So let's put the value. V is 24 volt and the total current is 5 ampere. So from this, what we see, the resistance or the total resistance is coming as 4.8 ohm, and that is the total resistance of the circuit. So we can even mention it here. The total resistance is 4.8 ohm. Now, point to remember here is that in case of a parallel circuit, the total resistance that we have obtained is actually smaller than R1, R2 and R3. You can see R1 is 8 ohm, R2 is 20 ohm and R3 is 30 ohm. And the value that we have got as the answer is even smaller than the smallest value, that is 8 ohm. This is a very, very important concept in case of parallel circuits. Okay, now there is another way to solve total resistance. So what we can do directly, if you don't want to use any of the formulas that we have learned right now, this is a basic formula we know, 1 by R. I can call this as RT or RP. Let me call this as RT only for R total. This is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is one way to calculate the total resistance. So what we can do now, we can put the values and then take LCM. So this will be 1 by 8 plus 1 by 20 plus 1 by 30. So what will be the LCM of 8, 20 and 30? It should be 120, right? So if I now solve this further, I will be getting here as 15. This will be 20 times 6, so this will be 6, and 30 times 4, so this will be 4. So if I add this further, this will be 25 by 120, but this is 1 by RT. But what we are supposed to calculate is RT, not 1 by RT. So this is where children make the mistake most often. They just write the answer as 25 by 120 by solving it further. We need to calculate RT, not 1 by RT. So here what we can do, we can just do the reciprocal. So RT will be equals to 120 by 25. So if you solve this, it would be coming, let me simplify this here. That will be 5 and this will be 2 and 4. 24 by 5 and that is going to be 4.8 ohm. So by both the methods, you will get the same answer. This is a direct formula to find the equivalent resistance of the parallel circuit. And if you remember, I have told you we can solve question number 1 and 2 at any time, because we can apply this formula at any time and we can find the total resistance. And after this, we can find the total current in the circuit. So now let's move to the next question. And this is numerical number 4. So in this numerical, we have got here 3 resistors again. First is of 10 ohm, second 60 ohm, and third 60 ohm again. And they are connected in parallel. And we are supposed to find the voltage across each resistor. And then we're also supposed to find the current in each resistor. So try this question yourself, and then I'm there to give the answer anyway. So I hope you have tried. Now let's see the solution. So for the first part, to find the voltage across each resistor, we know the concept, that is voltage across each resistor in parallel circuit remains same. Since our supply voltage is 15, so the same voltage is supplied across R1, same voltage is applied across R2, and even across R3 it is 15 volts. So we can write our answer here. Voltage across resistor R1 is 15 volt, across R2 it is 15 volt, and across R3 it is again 15 volt. So this is the answer to question number 4. I hope it is very clear to everybody. Now let's move to the question number 3, and that is to find the current through each resistor. Since I have explained this in the previous numerical, I'm going to run fast here. So current through resistor R1, then through resistor R2, and then through resistor R3. Let me call this current as I1, and then here I can call this as I2, and then this as I3. So in order to find the current I1, we can use Ohm's law, and that is I1 is equals to the supplied voltage, that is 15 volt, divided by its own resistance. I'm calling it as R1. So I1 is equals to 15 volt divided by R1. We can put the values and calculate here. That is 15 volt divided by 10 ohm, and that is coming as 1.5 amperes. Now let's calculate I2. I2 is equals to the supply 15 volt divided by the resistance R2 is 60. Let me write here 60 ohms. So this will be 15 by 60, that is 1 by 4, and that is equals to 0.25 amperes. Since R2 and R3 have same value and they are connected in parallel, you'll find that the answer of I3 is also going to be same. This is 15 volt, that is the supply voltage across R3, and its own resistance, that is 60 ohm. So here you'll get the same answer, 1 by 4, and that is 0.25 amperes. So this is how we find question number 4 and 3, the voltage across each resistor and then the current through each resistor. Now we have 2 more questions. Question number 1, that is to find the current, total current through the circuit. So this is what we are supposed to find, the total current that is just coming out from the source here. We need to find this current. For this, we know I1, that is the current flowing through R1. Then we also know I2, that is the current flowing through R2, and then I3. We know the concept. The total current I that is flowing in the circuit is the sum of current that is passing through each resistor. It's given here in parallel circuit. Total current is the sum of current through each resistor. Since we know the value of I1, we have just now calculated. I1 is coming as, it was 1.5 amperes. I2 is coming as 0.25 amperes and I3 is coming as 0.25 amperes. So we can directly add all the values here. Total current I is equals to sum of I1 plus I2 plus I3. Let's add them all. We have 1.5 ampere plus 0.25 amperes plus 0.25, and that is going to give us 2 ampere. This is the total current that is flowing in the circuit, and we can mention this as 2 amperes. Now, if you remember the last solution, we have to find total resistance, and for that, what we are basically doing, we are finding one resistor that will be equivalent to this 3, right? And that resistor, we are calling it as total resistance RT. So in order to find this, there are two methods. So the first method is, what we can do, we can take the same total current as 2 ampere here, that is in the circuit, and use simply Ohm's law. The supply voltage remains same. So here we can use, this was your solution to question number 2. And for question number 1, we can use Ohm's law in this circuit, right? In this circuit, we have to use Ohm's law. So it will be R is equals to V by I. This is the Ohm's law. But we want to find RT, that is the total resistance. And for that, I will take the total current. So I'm calling it as IT, which is nothing but this is IT. I'm writing it here. So if you put the values, V is 15 volt, the supply voltage, and the total current, that is 2 amperes. So 15 by 2, that's coming as 7.5 ohm. This is the total resistance of the circuit. I'll again remind you, the value that you obtain, do cross check. In case of parallel circuit, this value should be smaller than the smallest value here. The value 7.5 is smaller than 10. It is even smaller than 60 and 60. This is important concept. In case of a parallel circuit, the equivalent resistance is smaller than the smallest value in the circuit. Okay, now there's another way to solve the total resistance that we discussed earlier. We can use the direct formula to calculate total resistance, and that we know 1 by RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Let's put the values directly. This will be 1 by 10 plus 1 by 60 plus 1 by 60. Rest, I know it's all simple. We can take the LCM as 60. So 10 times 6 is 60. So I'll write this as 6 plus 1 plus 1. And that's coming as 8 by 60. Again, a reminder, this is not RT. This is 1 by RT, and we are supposed to calculate RT. So we can do the reciprocal here and write 60 by 8 is equals to RT. We can divide this. We can simplify this further using the table of 4. This will be 4 times 2 is 8, and this is going to be 15. So 15 by 2, we got this value in the last step also. This is coming as 7.5 ohm. And this is the equivalent resistance of this parallel circuit. So this is all about numerical 4. I hope the concept of solving parallel circuit is crystal clear to everybody. Now I'm going to summarize this parallel circuit and series circuit in the next moment. So what are the key concepts? In case of a parallel circuit, the concept 1 is, in parallel circuit, voltage remains same. So if the supply voltage is, let's say 10 volt, 20 volt, the same voltage will be applied across each resistor. This is concept number 1. Now concept number 2 is about current. This is about the voltage. Now this is about the current. So it says in parallel circuit, total current, that is this one, total current is the sum of current through each resistor. So this will be the sum of current, that is I1 plus I2 plus I3. This is the concept. We can write this as total current I is equals to I1 plus I2 plus I3. Now, the technique to solve parallel circuits that we have been using in the session is we start with question number 4, then we solve number 3, 2 and 1. 4 is basically we solve or find the voltage across each resistor and then we find the current through each resistor. Okay, that is all about parallel circuits. Now let me summarize the key concepts of both series and parallel circuits together. Sometimes in your exam the question can be asked, differentiate between series circuits and parallel circuits. So you can write this directly in your answer. So what are the points? We have 3 points to note. The first point is, in a series circuit, current remains same. So whatever is the current that is flowing in the circuit, same current will be flowing through each resistor because there is only one path. Now, whereas in case of a parallel circuit, what remains same is not the current, but voltage across each resistor remains same. If I call this as V's, then the same voltage will be applied across each resistor. Now, what's the point number 2? The key concept is, in a series circuit, the supply voltage is divided proportionally. You can understand this in a different way. You can say the total supply voltage, that is this one, is the sum of voltage difference across each resistor. So if you are going to add this V1, the voltage difference across R1, the voltage difference across R2, and the voltage difference across R3, if you add them up, this will be equals to V1 plus V2 plus V3. So you can say in other way, this V is actually divided proportionally between R1, R2 and R3. Okay, now same way for parallel circuit, what we can say, the total current, that is this current I, the total current is equal to the sum of current through each resistor. If this is your I1, this is your I2, this is your I3. So the total current, this I, will be the sum of I1 plus I2 plus I3. Okay, this is what many students are familiar with, but there is another difference, very, very important, from where the questions are mostly asked, and it is in series circuit, the equivalent resistance, that is the total resistance, is actually more than the individual resistor. So when you find the total resistance, the value is always going to come higher. Whereas in case of a parallel circuit, the equivalent resistance is actually less. It is smaller than the smallest value in that circuit. So these are the basic concepts of series and parallel. We will be solving some questions based on this little later. And that's all for today's class. I hope you enjoyed today's session, and we will meet in the next session. Till then, bye bye, take care and happy learning.